There's all possibility of asking questions of like this. So when I project it, so let it come and strike the edge of this. I projected with a speed u at an angle theta. Then the gravity will act. Again, we'll choose some points. So here it will have speed v1, u cos theta, speed v2. Here it will have speed u only, and it will come and strike the other corner of the tower with a speed v. So it's going to move in a parabolic path. Why parabolic path? Again and again, why parabolic path? Weight mg, velocity. So it should move in a resultant path. This is one basic idea. See, like here particle is there. Weight mg will act, velocity. How it should move? Like this. If you project a particle and velocity, how it should move? Should move in this direction. If you project with a velocity and weight is acting, how it should move? Parabolic path, some curved path. Resultant, it should not move along mg or along u, in between the resultant. It should deviate away from the velocity. If it is projected, then okay, I think this is all the projectile motion what we are discussing. Come for this one. This is the position of the ball. Once again, what is the horizontal acceleration along is 0. So therefore, what will happen to horizontal component remains same. Vertical component will keep on changing. Here, horizontal component, u cos theta, u sin theta. If they are given this distance between the towers, we can take help of that one. Now, what we have to do? We have to write some equation. At t equals 0, we have projected. And after some time t, it will come and strike here. Then what is the displacement? First of all, writing equation. First, we have to calculate time of flight. Then, so there's the initial point. So we'll write down all the data. This is the initial. Where it will come and strike, this will be final. I'll look at the initial and final. Let's write the equation. First, time of flight. We have to calculate this time of flight. What time it will take to move in a parabolic path from one tower to the other tower. Then when it moves from here to here, what is the displacement? Vertical displacement will be this much now. And how much vertical displacement? Capital H, this small h. And how is the displacement is measured? Downward, no? So therefore, there should be h minus h, negative sign, equal to u sine theta t minus g t square by 2. Once again, so why negative sign? Because this displacement is measured opposite to u sine theta. Then how g is acting? Opposite to u sine theta. This all, once again, I think I am repeating n number of times so the students can really stress on this particular thing. See, what is all? The entire projectile motion is what? Writing equations of motion. If you learn how to write this equation, that's what the projectile motion. Some students, they usually complain, sir, you repeat so many times. The important thing is what I should repeat. The necessary thing, why I should speak. You look at all projectile motion, how you solve, applying equations of motion. So what we should be very good now, how to use equations of motion. Hope everyone getting. Then solving this will get the time of flight. Then what about the range? Range is given by ux t plus ax t square. U cos theta 0. Then vy square uy square 2 minus g. There is so many things are there. Y minus vy. This vy is opposite to u sin theta. Yg negative. These two are opposite. Y displacement negative. How you measure displacement? You measure vertical displacement opposite to u sin theta. No? Okay, fine. So writing this equation is what all the problems solve. Then this will be vy square. Substitute the values and solve for vy. Then we'll get v equal to vx square plus vy square. Then we can also calculate that angle. No? This angle. Okay, this is one generalized idea which I'm sharing with you. So please try to understand and try to work out some different projectile motion, because this will become basic for your whole physics. Because once you know how the particle will move. So we'll summarize briefly.